Students, in the last period we have studied the zeros of linear polynomials and also geometric meaning of zeros of linear polynomials. Today we shall study geometrical meaning of zeros of quadratic polynomial. Here I have taken one example for quadratic polynomial. Here p of x equal to x square plus 6x plus 5 is a quadratic polynomial because the highest exponent here exponent is 1, here 2, highest exponent is 2, and it is in the form ax square plus bx plus c. P of x equal to ax square plus bx plus c. So this is general form of the quadratic polynomial, and the given polynomial is of this form, therefore it is a quadratic polynomial. Now we shall draw the graph of this quadratic polynomial. To draw the graph of this quadratic polynomial, let us take y equal to x square plus 6x plus 5. Now we are trying to understand the geometrical meaning of zeros of quadratic polynomial. I have taken one example, that is x square plus 6x plus 5. Here y equal to x square plus 6x plus 5. We shall calculate the value of y corresponding to the values of the x. So let us take x equal to minus, this side I'll write y equal to our equation, our polynomial is x square plus 6x plus 5. I will put x equal to minus 5. Here minus x equal to minus 6 I will put first. Minus 6 square plus 6 into minus 5 plus 5. This is equal to 6 6 are 36, 6 5 are 30 plus 5. So 36 plus 5 41, 41 minus 30, 6 6 are 36. X is 6, I should take it as 6 here. So your point will be 6 6 are 36, 6 6 are 36 plus 5 plus 36 minus 36 cancelled 5. So y value is 5. When x is minus 6, y is 5. Now let us, we shall take x equal to minus 5. If I take x equal to minus 5, minus 5 square plus 6 into minus 5 plus 5. 5 5 are 25, 6 5 are 30 plus 5. 25 plus 5, 30. 30 minus 30, 0. So when x is minus 5, y is 0. Now we shall take x equal to minus 4. If I take x equal to minus 4, minus 4 square plus 6 into minus 4 plus 5. This is equal to 4 square is 16, 16, 6 4 are 24 plus 5. 16 plus 5 is 21, 21 minus 24 is minus 3. So here minus 3. Now we shall take x equal to minus 3. If I take x equal to minus 3, here put minus 3, minus 3 square plus 6 into minus 3 plus 5. This is equal to minus 3 square is 9, 6 3 is 18, minus 18 plus 5. 5 plus 9, 14, 14 minus 18 is minus 4. This is minus 4. Similarly, take x equal to minus 2. Now take x equal to minus 2 square plus 6 into minus 2 plus 5. This is equal to 4, 6 2 are 12 plus 5. 4 plus 5, 9, 9 minus 12 is minus 3. Here minus 3. Now take x equal to minus 1. If I take x equal to minus 1, 9 square plus 6 into minus 1 plus 5. equal to minus 1 square is 1. 6 on the 6 plus 5. So 1 plus 5 6, 6 minus 6 0. This is 0. Now take x equal to 0. When x is 0, put 0 here, 0 square plus 6 into 0 plus 5, 0 plus 0 plus 5, this is 5. So when x is 0, y is 5. Now we have found the coordinates. We shall draw the graph. First point is minus 6, comma 5. X coordinate is minus 6, y coordinate is 5. Here minus 6. We shall go here on the x-axis minus 1, minus 2, minus 3, minus 4, minus 5, minus 6 here. Y coordinate is 5. So 1, 2, 3, 4, 5. Come here. This is the point. This point is minus 6, comma 5. Next point minus 5, comma 0. Minus 5. Minus 1, minus 2, minus 3, minus 4, minus 5 here. And y value is 0. Means we are not moving up or down side. 0. This point is minus 5, comma 0. Next one minus 4, comma minus 3. Minus 4 is here. Minus 1, minus 2, minus 3, minus 4 and minus 3 here. You come here. This point is minus 4, comma minus 3. Next point minus 3, comma minus 4. Minus 3 is here. Minus 4 is here. Come here. This is the point minus 3, comma minus 4. Next point minus 2, comma minus 3. Minus 2, minus 2, comma minus 3 here. Minus 2, it is minus 3, it comes here. Minus 2, comma minus 3. Next one minus 1, comma 0. Here this is minus 1 and 0 means on the x-axis. If y value is 0, we are not going upside or downside, it is on the x-axis. This point is minus 1, comma 0. Then next is 0, comma 5. 0, comma it is 5. So 0 is x0 means on the y-axis. We are not going this side or this side. 0, comma 5. 0, comma 5 is here. 0, comma 5. x0, y 5. Now we shall draw graph. We are drawing the curve. This is the graph of the quadratic polynomial x square plus 6x plus 5. Polynomial, given polynomial is, I will write this side, p of x equal to x square plus 6x plus 5. This is the given polynomial. Okay, the graph of this quadratic polynomial is of this shape. This shape. So all quadratic polynomials, the graph of all quadratic polynomials will be of this shape or this one. There are two shapes. It is open curve facing upside or open curve facing downside. There are two types of graphs. Here, what are the zeros of these polynomial? We shall see. Zeros of this polynomial. First, directly I will take the zeros. For example, if you take x equal to minus 1, if you take x equal to minus 1, what happens? Minus 1 square plus 6 into minus 1 plus 5. This is equal to 1 minus 6 plus 5, 5 plus 1 6, 6 minus 6 0. We got 0, polynomial value is 0, therefore minus 1 is a 0. 0 of the polynomial is minus 1. Another 0 is there. What is another 0? Here let us put x equal to minus 5. If I put x equal to minus 5, what happens? You see, minus 5 bracket square plus 6 into minus 5 plus 5. So minus 5 square is 25, 6 5 are 30 plus 5. 25 plus 5 is 30, 30 minus 30 is 0. Again we got polynomial value 0. So this x value is 0. So another 0 is minus 5. We have got two zeros. Minus 1 and minus 5 are the zeros. Here from the graph, what are the zeros? Minus 1 is here. Minus 1, x. This is minus 1. Value of x is minus 1. When y is 0. When y is 0, x value is minus 1. When y value is 0, x value is minus 5. When y value is 0, x value is minus 1. So minus 1 and minus 5 are the zeros of the given polynomial. That is, once again, just I will tell you, p of x equal to x square plus 5x plus what are the polynomial? X square plus 6x plus 5, x square plus 6x plus 5. So here, when its value becomes 0, we call the value of the x as a 0 of the polynomial. So when this value is 0, that is when if I take y equal to x square plus 6x plus 5, when this is equal to 0, then corresponding value of the x is 0 of the polynomial. That is when y is 0. Here at this point y is 0, corresponding value of x is minus 1. When y is 0, x value is minus 5. So minus 1 and minus 5 are zeros of the polynomial. Now here, what are the zeros? Zeros are the x coordinate of the point. X coordinate of the, or zeros are the x coordinates of the points where the graph cuts the x-axis. Here this graph, okay, this curve representing the given polynomial cuts the x-axis at this point. At this point, x coordinate is minus 1. So minus 1 is 0 of the polynomial. And this curve cuts the x-axis at this point. At this point, x coordinate is minus 5. So minus 5 is 0 of the polynomial. What are the zeros of the polynomial? The x coordinate of the point where the graph cuts the x-axis. Here the graph cuts the x-axis at 2 points. Here this is one point, this is another point. So there are two zeros for this given polynomial. Just I took one example. For this given polynomial, there are two zeros. Okay, so this graph can cut the x-axis in 2 points, or it can cut the x-axis in only 1 point, or it may not cut. For example, here the graph can be like this. Here graph just touches the x-axis. Graph touches the x-axis, meaning here the two zeros, here two zeros were there, minus 1 and minus 5, two zeros were there. Now what we say, this kind of two zeros converge. They converge into a single point. That is this kind of graph, or this graph represents a polynomial. Particular polynomial represents this graph. Okay, the zeros of that graph are 3 and 3. We say it has only one zero, but repeated zeros, that we are going to study later. Right now what we say, this polynomial which represents this graph has only one zero. For example, if it has not cut the x-axis, it can be like this also. If it is like this, it is not touching the x-axis. It is not cutting the x-axis. What we say, there are no zeros, because if it cuts x-axis, then only we can say there are zeros. That is the x coordinate of the point where the graph cuts the x-axis. Then we say those are zeros, that is the x coordinates are zeros. But first of all, this graph is not cutting the x-axis. If there is not cutting the x-axis, there are no zeros. So the quadratic polynomial can have two zeros or one zero or no zeros. Quadratic polynomial can have two zeros or one zero or no zeros. These are the possibilities. At the most, quadratic polynomial can have maximum two zeros, not more than that. I think you have understood. The graph can be like this also. Here it is cutting in two places, means it has two zeros. Now we shall find the relation between the coefficients and zeros of the quadratic polynomial. Let us consider on quadratic polynomial here. Just what we saw, that is what we studied, the quadratic polynomial. Same polynomial I will take p of x equal to a x squared plus 6x plus 5. We took one example. The same example I will take now. So p of x equal to find zeros of the polynomial. Okay, we factorize this x squared plus 5x plus x plus 5. That is, we are going to split the middle term in such a way that sum of these two should give 6 and product of this should give 5. Okay, here what is common here? Here in this case x is common, x plus 5. Here nothing is common, means 1 we can take common, 1 into bracket x plus 5. So this further we can write it as x plus 5, another bracket x plus 1. To find zeros, we take this polynomial equal to 0 and find the values of x. Now x plus 5 is 0, or x plus 1 is 0, or x equal to minus 5, or x equal to minus 1. So minus 5 and minus 1 are the two zeros of this polynomial. Minus 5 and minus 1 are two zeros of the polynomial. Now I want to find the relation between the coefficients and zeros. So let us, we shall compare this equation with the general form. General form is p of x equal to ax square plus bx plus c. In this case, a value is 1. A value is 1. Compare these two terms, x square term. What is the coefficient of x square? A. Here what is the coefficient of x square? 1. So a is 1. B, coefficient of x is 6. Here coefficient of x is b, so b is 6. Then c is a constant term, so c is 5. Okay. Now I will erase this much portion. I'll erase this much portion. And you have already, you have come to know zeros are minus 5 and minus 1 are zeros. Here we have reached this polynomial value x square plus 6x plus 5 is equal to x plus 5, another bracket x plus 1. When zeros are minus 5 and minus 1, here we have written x plus 5, x minus 1. For example, if zeros of a quadratic polynomial, this quadratic polynomial, if zeros are alpha and beta, if zeros are alpha and beta, then if zeros are alpha and beta, that is zeros of the quadratic polynomial, I'll write here. Quadratic polynomial is ax square plus bx plus c is the quadratic polynomial. If its zeros are alpha and beta, if zeros are alpha and beta, then like this we can write x into bracket minus alpha, another bracket x minus beta, x minus beta. Just compare here. Here 0 was minus 5, here plus 5 is written, here minus 1 plus, here alpha is positive, beta is positive, that is we have taken two zeros alpha and beta. So using this you can write it as x minus alpha into bracket x minus beta. Now multiplying these two, x into x, x square, x into beta, beta x, alpha into x minus alpha x, alpha into beta minus minus plus alpha beta. This is equal to x square minus into bracket alpha plus beta into x plus alpha beta. Okay, here we have considered one example. This example again I'll take here. Here there can be 1, or if for example if this equation is multiplied by 2, x square plus 6x plus 5, this polynomial becomes 2 into x square, 2x square, 2 6 are 12x plus 10. Now this polynomial and this polynomial both are same, both are equivalent. For example, if I write reverse, 2 if I take common, it becomes x square plus 6x plus 5. So there can be but one constant here. So I will take that constant here as a k. Here also k will come. Then here k. One more step I'll write k into x square minus k into bracket alpha plus beta into x plus k alpha beta. Now comparing the coefficient of x square. Here coefficient of x square is a. Here the coefficient of x square is k. So a is k. Then coefficient of x is b. Here coefficient of x is minus k into bracket alpha plus beta. Minus k into bracket alpha plus beta. Then c equal to k alpha beta. K into alpha beta. We have got a, b and c values. We want to find what is sum of zeros. Alpha plus beta is how much, and we want to know what is the product of zeros, alpha beta. So from these we can find alpha plus beta and alpha beta. Now what I'll do, I'll calculate b by a. If I calculate b by a, b value is how much here? Minus k into bracket alpha plus beta. A value is k. K cancel. So b by a equals minus alpha plus beta, or we can write it as alpha plus beta equal to minus, take this side, it becomes minus b by a. Alpha plus beta is sum of zeros. Sum of zeros is alpha plus beta, that is minus b by a. Similarly, if I calculate c by a, c is k alpha beta, divided by a is k cancel, so alpha beta equal to c by a, or c by equal to alpha beta. Here we have got a relation between zeros and the quotients. What is a polynomial? Polynomial is p of x equal to ax square plus bx plus c. Now, if alpha and beta are the zeros, if alpha and beta are zeros, if alpha and beta are zeros, of this polynomial, p of x equal to ax square plus bx plus c, then sum of zeros is given by alpha plus beta. Sum of zeros alpha plus beta is given by minus b by, and product of zeros is given by alpha beta equal to c by. We are going to use these two relations to solve the problems. Okay students, we shall use this and solve some problems. Next video we shall solve some problems. Thank you.